Proving trigonometric identities, problem type 1. As we saw in the previous video verifying a trigonometric identity, there are 4 major identities that we can play around with. For the most part, we're just going to be looking at the reciprocal, ratio, and Pythagorean. Some of the others will come up every now and then. So let's just dive in and see what we're working with. As an example, I might want to look at sine squared theta minus cosine squared theta is equal to 1 minus 2 times the cosine squared of theta. When we are trying to prove an identity, we really don't want to use properties of algebra to manipulate the equation. The notation that we use is to start with one side, traditionally the left-hand side. Every now and then you'll find a situation where starting on the right-hand side makes more sense. And just work through, step by step, line by line, ways that we could rewrite everything. What I notice right away in this particular expression is that on the left-hand side, I have both sine and cosine. On the right-hand side, I have only cosine. And because I have things being squared, my mind goes to the Pythagorean identity. Instead of using it in the normal form of sine squared theta plus cosine squared theta equals 1, I'm going to rearrange things a little bit and solve that for sine squared theta is equal to 1 minus cosine squared theta. And then substitute that into my expression over here. Instead of calling that sine squared theta, I now know I can call it 1 minus, see if I can actually write. Instead of calling that sine squared theta, I can now call it 1 minus cosine squared theta. And then I still have the minus cosine squared theta to go from there. Then I have a cosine squared theta, and I have another cosine squared theta. I can combine some like terms, what our textbook calls an algebra step, to write this as 1 minus 2 times the cosine squared of theta. And that, in just a couple of steps this time, is exactly what we saw on the right-hand side of the identity we were trying to prove. So by using known identities, we were able to prove this new identity. Putting some sort of a mark to say that, hey, I finished proving that is traditional. Squares or rectangles that we fill in like this is quite common, but not necessary. If you're going on in further math, though, that's something that you'll see again in the future.